So in this problem, we need to show that cosine squared 2x minus cosine squared 6x, that's equals to the product sine 4x and sine 8x. So let us begin. Now, in order to solve this particular problem, we can use two identities. One identity being, so let's say we have cosine of angle A plus B multiplied to cosine of angle A minus B. So this is actually equals to cosine squared A minus sine squared B. And in the other case, we have, if we say, let's say we have the product of the sine of angle A plus B and sine of angle A minus B. In that case, this was equivalent to sine squared A minus sine squared B. So these are known identities. Now in the case, we have cosine squared 2x minus cosine squared 6x. So it's not satisfying either of the two cases. Now what we can do, we'll have to further simplify the left hand side. So we'll begin from the left hand side of a given problem. So here we have cosine squared 2x minus cosine squared 6x. But what you can do, we can convert both this cosine function to sine function by using the fact that whenever we have sine squared theta plus cosine squared theta, so that becomes equals to 1. And in our case, since we need to convert cosine squared theta to sine squared theta, all we can do is replace cosine squared theta with 1 minus sine squared theta. That means cosine squared 2x is going to become 1 minus sine squared 2x. Minus, we have cosine squared 6x, so that will become 1 minus sine squared 6x. So luckily, the 1 will get cancelled out, and we will be left with sine squared 6x minus sine squared 2x. So this has a familiar form as this one. So that means we can now also express it as sine of 6x plus 2x. This is sine squared 2x times sine of a minus b. So that will be 6x minus 2x. So sine 6x plus 2x, that will be sine of 8x multiplied to sine 6x minus 2x, so that will be simply sine of angle 4x. And this is the expression on the right hand side. Hence,